Okay, so let us start the set of exercises now. So the first four exercises, in them we have to find the increments when a particle is moving from point A to point B in the coordinate plane. The first one is this is where the particle starts its journey, and this is where it ends its journey. So the increments in the x and y coordinate are delta x. So this is the x coordinate of the particle's final position minus x coordinate of the particle's initial position. -1 minus 3. So this is equal to 2. Like that, delta y is -2 minus -2. So this is 0. Number 2, A has the coordinates -1, -2, and B has the coordinates -3, 2. In this case, delta x is -3 minus 1. That means -3 plus 1, so this is -2. And delta y is 2 minus -2. So this is 4. Then in 3, the points are A -3.2, -2, and the final position is -8.1 and -2. Delta x is -8.1 minus -3.2. -4.9. Yes, and delta y in this case is again 0, like this one. And number 4, A has the coordinates square root of 2, 4, and B has the coordinates 0, 1.5. Zero minus square root of 2, so this is -√2, and delta y is 1.5 minus 4 minus 2.5. Please check the numerical values. Okay, because it's natural that I may make a mistake. Then describe the graphs of the equations in exercises 5 through 8. x square plus y square is equal to 1. Okay, the given equation is equivalent to square root of x square plus y square equal to 1. The given equation of course implies this one. This one also implies this one, because when you take square, the square and square root, they cancel each other, and that is because x square plus y square is always a non-negative real number. So these two are equivalent. If one is true, then the other is also true. This implies the given equation. Okay, how should we write this? The given equation represents the set of all points whose distances from the origin are all equal to 1. Or we can more informally write, instead of writing set of points, represents those points px comma y in the plane whose distances from the origin equal 1, because we already know that this quantity, this expression square root of x square plus y square, is the distance of this point from the origin. So the graph of the equation is the unit circle. Recall that the unit circle has radius 1 and center at the origin, so it is the unit circle. Then 6, x square plus y square equal to 2. The given equation is equivalent to this. So the graph, I mean, we have written the reason once. In fact, it has to be written in every solution, but of course I'm not going to repeat it. That the distance of, I mean, this represents all those points in the plane whose distances from the origin are all equal to square root of 2. So the graph is the circle with center at the origin and radius square root of 2. And the seventh one, x square plus y square is less than or equal to 3. Given, we should not write equation here, it's an inequality. The given inequality is equivalent to this. So it represents those points px comma y in the plane whose distances from the origin are less than or equal to square root of 3. Hence, the graph is the circle with center at the origin and radius square root of 3 along with its interior. Inside the circle also, the points inside that circle, for each such point, its distance from the origin is strictly less than square root of 3. So they are also included, and that's why we will have this. The circle is there, this is the x-axis, this is the y-axis. This point has the coordinates square root of 3 comma 0, that means the radius is square root of 3, along with all the points that lie in the interior. So it's that disk. Okay, that is the graph of this inequality. Then 8. The 8th one is somewhat interesting. X square plus y square equal to 0. x square plus y square is equal to 0 if and only if x equal to 0 and y is equal to 0. If these two equations are true, then of course the sum of their squares is also equal to 0. Conversely, if this is equal to 0, then because x square and y square are both non-negative, so each one should individually be 0. If one of them is say positive, then the other cannot make it 0 because it cannot be negative. So that's why x square should be 0, y square should also be 0, but then x and y are 0. So the graph in this case is the single point, that is the origin. Okay, for this equation, this is the only point in the plane that satisfies the equation. So in this case, it's a rather peculiar case, but nevertheless a case in which there is only one point in the graph. Okay, so after this, slopes, lines and intercepts. Plot the points in exercises 9 through 12. And find the slope. If any, because you may get a vertical line also which has no slope of the line they determine. Also find the common slope, if any, of the lines perpendicular to the line AB. Okay. If any of the lines perpendicular to the line AB. Okay, now there are 4 exercises. Since we have to draw, so let us just draw all of them together, and for each one of them we will find the things. So we write a common solution. First, let's take the exercises down, I mean the actual points. A has the coordinates -1, 2. B has the coordinates -2, -1. Okay. then 10. A has the coordinates -2, 1, and B is 2, -2. 11. A is 2, 3. B is -1, 3, and 12. A is -2, 0, and B is -2, -2. Okay, so among all these points, the maximum x coordinate is 2 and the minimum is -2, whereas the maximum y coordinate is 3 and what is the minimum? Minimum is -2. Okay, so let us draw the axes accordingly. We have plenty of room for drawing these lines because the coordinates don't have huge values. Have we been asked to draw? We have not actually been asked to draw the lines, but we will draw them. We have only been asked to plot the points and then calculate the slopes from the values, but we are going to draw the lines so that we can see how the lines look. One, two, three, -1, -2. Since the coordinates have not gone below -2, so this much is enough. And then 1, 2, 3. Let me extend this a little bit. -1, -2. Okay, so this is the x-axis, this is the y-axis. For the ninth one, this is -1, 2. So this is -1, 2, and -2, -1. -2, -1. So this is the line. To distinguish the points from one another, let's just temporarily name this point A9. It belongs to the 9th exercise. And this is B9, -2, -1. Okay. Then let's draw the 10th one also. -2, 1. This point and 2, -2. -1, -2. this is A10 minus 2 comma 1, and this one is B10 2 comma minus 2. Then the 11th one, A is 2 comma 3, and B is minus 1 comma 3. Oh, okay. So this line is horizontal. A11 2 comma 3, and this is B11 minus 1 comma 3. And then A minus 2 comma 0, so this one, and B is minus 2 comma minus 2. A12 minus 2 comma 0, and this is B12 let us calculate the things here. So we have plotted the points. In fact, we have drawn the lines also. Now we want to calculate the slopes of the lines and the common slope of the lines perpendicular to the given line. For example, if you look at this line, there are infinitely many lines perpendicular to this line. They all will have the same slope because they are all parallel to one another. That also we have to find. So what is the first one? The first one is A9, this one. So the slope of A9 B9 is, so you just have to apply the formula. The y increment, let's just subtract oh sorry, what am I looking at? This is B9 and this is A9. So let's just subtract the coordinates of B9 from the coordinates of A9. It does not matter which way we do the subtraction, the ratio will ultimately have the same value. But we have to be consistent in what coordinates we are subtracting from what coordinates. If we are subtracting these coordinates from these coordinates, then we have to do it consistently. It should be 2 minus minus 1 and minus 1 minus minus 2, not 2 minus minus 1 and then minus 2 minus minus 1. That will give us a wrong result. So 2 minus minus 1, the y increment comes in the numerator, and in the denominator minus 1 minus minus 2. So 2 plus 1 is 3 and minus 1 plus 2 is 1. So this is equal to 3. So it is 3. The slope is 3, and you can see that the slope is positive and the line is going uphill as x increases, which matches with what we previously saw. The common slope of the lines perpendicular to A9 B9, that is this type of not that one, since this is the line, so this type of lines, for them what is the slope is the negative reciprocal, because when we multiply the slopes of two lines that are perpendicular to each other, then that product is -1. So it will be -1/3, which is understandable also. You see, if you have a perpendicular line like this, perpendicular to A9 B9, then it is going downhill but not too rapidly. The absolute value is 1/3, but it is going downhill nevertheless, and that is because of this minus sign. Like that, the slope of A10 B10 is, where is A10? A10 B10. So let's subtract these coordinates from these coordinates. So 1 minus 2 divided by -2 minus 2. So we get what? 2 plus 1 is 3, and in the denominator we have -4. So -3/4. The common slope of the lines please verify the numerical values. Okay, I am again repeating because there may be a mistake. Perpendicular to A10 B10 is, you take the reciprocal and multiply by -1. So you can see one thing. Here the original line is going downhill, and that is because of this minus sign. The lines perpendicular to it will go uphill in that direction, so they have positive slope. Then what is the 11th one? This one. It will have zero slope, no slope at all, because it does not tilt. And in fact you can see that from the formula also. You take the y increment is 0, you will divide the y increment by the x increment, so the ratio will be 0. The slope of A11 B11 is, you can either directly write 0 or you can show the formula also. Oh, sorry. See, we say something and something else goes on in our mind. 3 minus 3 divided by 2 minus -1 equal to 0. The lines perpendicular to A11 B11 are vertical because the given line is horizontal and hence have no slope or undefined slope. Oh, we should not write no slope because no slope usually means zero slope. Okay, I should not wrap this up, and hence have undefined slope. And finally we have a vertical line. So all the you can see that the author has covered all the cases, namely the given line is it can have positive slope, it can have negative slope, it can be horizontal, it can be vertical, and finally the slope of A12 B12 is undefined. The reason is clear. Either you can say it's undefined because the line is clearly seen to be vertical, or you can say it's undefined because the x increment is 0, so you cannot form the ratio of y increment to x increment. The lines perpendicular to A12 B12 are horizontal and so have common slope 0. So that's the thing, and it completes these 4 exercises. Okay, now after this, in exercises 13 through 16, find an equation for A the vertical line and B the horizontal line through the given point. We know that if a point is given to us in the plane, then there is one horizontal line and one vertical line passing through that point. We have to find equations for these lines. 13, the point is -1, 4 divided by 3. So without writing too much, we will just simply write the equations. The A is the vertical line. So all points on the vertical line passing through this point will have their x coordinates constant, because you see, let's just look at this case for once. in detail. These are the coordinate axes. Okay, this is x-axis, this is y-axis, and -1 comma 4 by 3, 4 over 3 is 1 point something, slightly greater than 1. So say we have -1 here and 1 here, so we will have the point here roughly. So if we draw the vertical line passing through this point, so this is my point, then they will have constant x coordinate. All the points on this line have x coordinate equal to -1. Y coordinate will vary, and depending on what the y coordinate is, the position of the point on the line will be determined. So the equation of this line is x equal to -1, and the horizontal line passing through this point is this. Just like this, on this line all the points will have their y coordinates equal to 4 by 3. X coordinate changes, and depending on the value of x coordinate, the point will lie at specific places on the line. So here the equation is y equal to 4 by 3. Now that we have seen one, we can now similarly write the others. Vertical means x is constant, horizontal means y is constant. 14. So these are the, in terms of finding, in terms of finding the equation for a line, horizontal and vertical lines have the simplest types of equations. So here also the vertical line has the equation x equal to square root of 2, and the horizontal line has the equation y equal to minus 1.3. This is the vertical line and this is the horizontal line. The vertical line in this case turns out to be the y-axis itself. Then 16. Here the horizontal line is the x-axis. Its equation is y equal to 0, because on the x-axis all the points have their y coordinates equal to 0. Okay. Now we come to equations of more complicated nature. Equations of straight lines nevertheless, but more complicated than this simple case. In exercises 17 through 30, write an equation for each line described. Okay, let me put some ink first. the 17th one passes through -1, 1 and with slope -1. So for such a line, we already know the type of the equation that we can write. The point slope form. You should of course write in the solution that an equation of the given line is like that. You have to write those words, but we are here simply going to write the equation and then we will simplify it to make it look good. Y minus 1 is equal to slope is -1 times x minus -1. That is, we subtract the y coordinate from y and we subtract the x coordinate from x and we have the equation in this form. If we simplify this, it becomes what? Y minus 1 is equal to, this is x plus 1, so minus x minus 1. That means -1 and -1, they cancel each other and we have x plus y equal to 0. Okay, so x plus y equal to 0. This line passes through -1, 1 clearly, because if you add -1 and 1 you get 0. So this point is on the line, and also it has slope -1 because y is equal to -x. Okay, moving on. 18 passes through (2, -3) with slope (1/2). Similarly, y minus -3 is equal to 1/2 times x minus 2, which is equivalent to, if we multiply throughout by, on both sides by 2, and we also have y plus 3, then we will have 2y plus 6 equal to x minus 2, which is equivalent to, if you rearrange the things slightly, x minus 2y equal to 8. So take 2y on that side, divide by 2, the slope is 1/2, and 2, -3. If you just you can do one thing after finding the equation and after simplifying it, to make sure that whatever you have done is correct, you can again substitute the coordinates of the point and check that it satisfies the equation. So you put 2 here and you put -3 here. -3 times -2 is 6 plus 6. 6 plus 2 is 8. So yes. Then 19 passes through (3, 4) and -2, 5. So here 2 points are given, the slope is not given, but using these 2 points we can find the slope. So here we will write something. The slope of the line is four minus 5 divided by 3 minus 2. That means this is minus 1, and in the denominator we have 5, minus 1 over 5. So the equation is, now once we have slope we can then write the equation, and just like we discussed previously in one of the worked out examples, in writing the equation we of course are going to use the slope, but we will have to use one of the points also. It does not matter which point we use, we end up with the same equation. So let's just use this one. Using that, the equation will be y minus 4 equal to minus 1 over 5 times x minus 3. If we multiply by 5, we will get 5y minus 20 equal to minus x plus 3. Which further simplifies to what? X plus 2y equal to, if we take minus 20 on that side, it will be 23. Okay. So if we put y equal to 4, then we get 8. What are we getting here? If we put y equal to 4, am I saying it correctly or have I done something wrong? (23). I think I made a mistake. Let me just re-verify. 4 minus 5, 3 minus 2. So this is 5, this is minus 1. So the equation is y minus 4 equal to minus 1 over 5 times x minus 3. I have then multiplied by 5. So that gave me 5y minus 20 equal to minus x plus 3. So that means x, see what I have written. I have written 2y, it will be 5y now. X plus 5y equal to, okay, now if we substitute y equal to 4, then 20 plus 3 is 23. Let's put the other point also and see whether it satisfies the equation. It has to satisfy. If we put y equal to 5, then 5 times 5 is 25. 25 minus 2 is 23. Yes. Then 20. Passes through minus 8, 0 and minus 1, 3. The slope of the line is 3 minus 0 divided by minus 1, there is minus 8, okay, so minus 8. So 8 minus 1, so this is 3 by 7. So the equation of the line is y minus, let's use this one, 0 equal to 3/7 times x minus minus 8. It may seem like a bit much to always write minus minus 8, but it helps us do the thing correctly and make less mistakes. (7y) equal to x plus 8, so 3x plus 24. We can keep the equation in this form. 21 has slope minus 5/4 and y-intercept (6). So we know how to write such an equation. It's quicker than finding a point slope equation. It's slope intercept equation, and the equation is y equal to mx plus c, where m is the slope and c is the y-intercept. Plus 6. So I leave it to you to rearrange the terms and make the equation look somewhat, what can I say, more I should not say more familiar, but make it look good. It will be 4y plus 5x plus 4y equal to 6. Then 22 has slope 1/2 and y-intercept -3. If you forget the form y equal to mx plus c, you need not worry. From the information that the y-intercept is 6, you can in fact find the equation using point slope form. This part of the hypothesis that y-intercept is 6 tells us that whatever the line is, it crosses the y-axis at the point 0, 6. So that gives us a point through which the line is passing and slope is given. So you can in fact write the point slope form of the equation. So in this case, the equation is just this. 23 passes through -12, -9 and has slope 0. Has slope 0 means it's horizontal. So the horizontal equation of a horizontal line is y equal to -9. Note that instead of using that fact that the slope is 0, the line is horizontal, and then writing the equation of the horizontal line passing through this point, you can just simply write like this. It will be y equal to 0. Oh, it's given to be passing through this point. Okay, slope, intercept is not given. Okay. No, I mistook it for this case. Okay, fine. So this is the equation. 24 passes through and has no slope. Okay, I think I said something wrong about this phrase no slope. No slope, I said that no slope means 0 slope, but now I think it means undefined slope. I'm not sure, I have to see the answers that are given at the end of this book, but I believe that in the way these exercises are going, by no slope the author means no slope at all, that is, slope is not defined. So that just tells us that the line is vertical, and so the equation will be x equal to 1/3. Has y-intercept 4 and x-intercept -1. So here both y-intercept and x-intercept are given. So it can be, you can find the equation in a number of ways. You can either use the information that the x-intercept is -1 and hence the line passes through the point -1, 0. There it crosses the x-axis, and then use the point, no, that will also not readily give you the equation. Okay, let's just solve it and then we will see. Since the x-intercept is, I think it's better to translate both the intercepts into the line passing through 2 points. Since the x-intercept is, or let's just write like this, x and intercepts are -1 and 4, respectively, the line passes through -1, 0 and 0, 4. So now 2 points are given to us. So the slope of the line is 4 minus 0 divided by 0 minus -1. So the slope is 4. hence it has this equation. Y, let's use this one, y minus 0 equal to 4 times x minus minus 1, which is equivalent to y equal to 4x plus 4. Let's just verify, okay. When x is minus 1, then minus 4 plus 4 is 0, so y is 0, fine. When x is 0, y is 4, yes. So this is the equation. Then 26 has y-intercept minus 6 and x-intercept 2. Actually, there is a form of the equation of a straight line whose 2 intercepts are given. Although we don't have that in this book, but using that form we can directly write the equation. If the x-intercept is, if I am remembering it correctly, x-intercept is say A and the y-intercept is B, then the equation is this. If we put the values here in this particular exercise, x-intercept is minus 1. So let me just see whether we get the same equation. X divided by minus 1 plus y divided by 4 equal to 1. Now if we multiply throughout by 4, we get minus 4x plus y equal to 4. Yes, y is equal to 4x plus 4. See, this is the equation of a straight line having x-intercept A and y-intercept B. You can prove this also very easily. You just have to find the equation of the line that passes through these 2 points. That will be this. Passing through these 2 points means having x-intercept A and y-intercept B. Okay, so in this case, the 26th one, x-intercept is 2. But since we have not we don't have this, we have to find in this way. Let's not write all the things, okay. First let us find the slope, the points, okay. Let us just write the coordinates of the points. The x-intercept is 2 means one of the points is this. Y-intercept is 6 means the other point is this. So slope is equal to minus 6 minus 0 divided by 0 minus 2. So slope is 3 and equation is this. Slope is 3. If we use this point, y minus 0 is equal to 3 times x minus 2. That means y is equal to 3x minus 6. 27 passes through passes through 5 comma minus 1. Just give me a moment, okay, let me see one thing. Okay, fine. So it passes through 5 comma minus 1 and parallel to the line 2x plus 5y equal to 15. Parallel lines have equal slope. The line 2x plus 5y equal to 15, or we can rearrange the things to bring it to a form where we can easily read off the slope. Y equal to minus 2 over 5 x plus 15 divided by 5 is 3 has slope minus 2 divided by 5. Now since our line is parallel to this line, so our line will also have this slope. So that's how we get the slope of the line, and it has to pass through this point. So the slope of the okay, we cannot write given line because this is the given line. Slope of the line whose equation we are seeking is also minus 2 over 5. Thus its equation is y minus minus 1 equal to minus 2 over 5 times x minus 5. Multiply throughout by 5, you get 5y plus 5 equal to minus 2x plus 10, or take 2x on that side, 2x plus 5y equal to 10 minus 5 is 5. You can notice one thing, that the equations of the line that we were trying to find and the equation of the given line to which it is parallel, they have the same left hand side. So this part will look the same for parallel lines. Their equations will only differ in their constant terms. Okay, this is a fact. Then 28 passes through minus square root of 2 comma 2 and is parallel to the line square root of 2 plus 2x plus 5y equal to square root of 3. So here we will just simply sketch the solution. First of all, this line is equivalent to this line y equal to minus root 2 divided by 5 x plus root 3 divided by root 2. So its slope is minus root 2 divided by 5. So this is the slope of our line also, and it passes through this point. So the required equation is this: y minus 2 equal to slope times x minus root 2. We can now simplify this. 5y minus 10 equal to minus root 2x. We have how many minuses? Minus, minus, minus. So this will be again minus. Root 2 is 2. Root 2x plus 5y equal to 10 minus 2, this is 8. So you see that thing is still true here. The given equation is of this form, and the equation we have found of the line is of this form. The left hand sides are of the, they are equal. The equations only differ in constant terms. So if you know this for a fact that this is always true, then you can find the equation in another way also. You don't have to find slope or anything. You will just simply write that the equation of the line we are seeking, since it's parallel to this line, is of this form: root x plus 5y equal to c, where c is a constant that we have to determine. And then you use the fact that this line passes through this point. So for x you will put minus root 2, for y you will put 2, and then you can find c, and you will see that c equals 8. But we cannot do that, of course, because we don't know for sure that this is always the case. It can be shown, but we don't need that right now. Then 29. Passes through 4, 10 and is perpendicular. Okay, this time perpendicular to the line 6x minus 3y equal to 5. The line 6x minus 3y equal to 5, or y equal to So you take 3y on that side, you divide by 3, y equal to 2x minus 5/3 has slope 2. So the slope of the line we are seeking is, it will be what? The negative reciprocal of this slope, because it has to be perpendicular to this line, so that when you multiply the two slopes it must be -1. So it has to be -1/2. Thus its equation is y minus, what is the point? 4, 10. Y minus 10 equal to -1/2 times x minus 4, or 2y minus 20 equal to -x plus 4, or x plus 2y equal to 24. In this case, here however clearly the left hand sides are not equal. You can in fact formulate a rule for writing the left hand side directly from here. That however is much more complicated than this simple one where the left hand sides are equal. Left hand sides of equations for two perpendicular lines are also related, although in a slightly more complicated way. And finally 30 passes through 0, 1 and is perpendicular to this line. 8x minus 13y equal to 13. So here we will simply write the things. The given line is this, whose equation can also be written equivalently in this form: y equal to 8 divided by 13 times x minus 13 divided by 13 is 1. So its slope is 8 by 13. Our slope, means the slope of the line we are seeking, is the negative reciprocal, minus 13/8. And our equation, the equation of the line we are seeking, hence will be this. The line is passing through this point, so y minus 1 equal to minus 13 by 8x, or 8y minus 8 equal to minus 13x, or 13x plus 8y equal to 8. So this is the equation. 8 and 13, they get swapped, 13 and 8. Here also there is a swapping, but we can't see it immediately. We have to in fact take 3 common out and then divide by 3. So that will give us 2 and minus 1, 1 and 2, and the sign also changes. It's somewhat complicated. So with this we end the video here today. Of course there are other exercises which we will solve in the next video. So that's it with calculus for today. If you are new here, please consider subscribing to my channel, A Mathematical Room. This is Lucifer signing off. Have a nice day.